So while coming to the next question, let's take it as the fourth question. So for TE10 mode of propagation in the rectangular waveguide filled with air, the broader dimension is the 2 centimeter and the cutoff frequency is. So let's take it as a rectangular waveguide, and here the A is the broader dimension and B is the shorter dimension, and they're given that the broader dimension is A is equal to 2 centimeter, and they're given the TE10 mode of propagation. So TE10 is the dominant mode in the rectangular waveguide, and so they are asking for the cutoff frequency. Before going to the cutoff frequency, that means generally lambda can be given as a C divided by F, and anyhow they given the medium is the air. That means here inside the rectangular waveguide air is there, and the TE10 mode is propagating like this. And now first we will find out the wavelength and then we will find out the frequency, because anyhow if air is a medium, then here C can be taken as a 3 into 10 power 8 meters per second divided by frequency. So first we will find out the wavelength of the rectangular waveguide. It is 2 divided by root of m by a whole square plus n by b whole square, and it is a wavelength for the TE mode mn. But here in the given question TE10 they are asking. So TE10 means m is equal to 1 and n is equal to 0, and they given the broader dimension A is equal to 2 centimeter. So now I am substituting all these values in this formula, that is m is equal to 1 and n is equal to 0 and A is equal to 2 centimeters. Now this expression can be shown as 2 divided by square root of 1 divided by 2. Actually they given the A in the centimeters, but here the C is in the meters per second. So that's why here I'm converting this 2 centimeter into the meters, that is 2 into 10 power minus 2 meters, and then so 1 divided by 2 into 10 power minus 2 whole square plus where n is the 0 by b whole square. So anyhow this entire term becomes is equal to 0, and here the square and the square root will get cancels. So finally it becomes is equal to, and then it becomes is equal to 2 into 10 power minus 2, that is 4 into 10 power minus 2. So here the lambda, that means the wavelength, I got as a 4 into 10 power minus 2, and but here in the question they're asking about the frequency. So from this expression the frequency becomes is equal to 3 into 10 power 8 by lambda, that becomes is equal to 3 into 10 power 8 divided by 4 into 10 power minus 2. So this entire one becomes is equal to 75 into 10 power 8, that becomes is equal to 7.5 gigahertz. So that means here the correct answer is 7.5 gigahertz. That means the first option is the correct one. So to solve this problem you must have the idea about this expression and this expression. And now while coming to the next question, that is in a plane traveling wave, electric and magnetic energy densities are equal, or else electric energy density is more than magnetic energy density, magnetic energy density is 0, electric energy density is less than the magnetic energy density. So if you observe the electromagnetic wave, the expression or the relation between the electric field intensity and the magnetic field intensity can be given as H is equal to E divided by intrinsic impedance. Okay, it is a relation between the magnetic field intensity and the electric field intensity. So from this expression you can understand that definitely H is less than the electric field intensity. Why? Because E can be taken as intrinsic impedance into H. So if you observe this relation, E is more comparing with the H. That means electric field is more comparing with the magnetic field. That means electric energy is more comparing with the magnetic energy. So that means electric energy density is more than the magnetic energy density. So here the option B is the correct one. So here only the option B is the correct one. So with the help of this theory we can go to this second option, that is B is correct, and obviously the C is wrong, A is also wrong, and the D is also wrong. Okay, but here the correct, the suitable option is the second one. And coming to the next question, Read the following statements regarding antennas. The rhombic antenna is a non-resonant antenna, and the Marconi antenna is a not wideband antenna, and horn antenna is best excited from a waveguide. So, of course, here all the three options are correct. If you see the structures, it is a rhombic antenna, and it is a Marconi antenna. Marconi antenna is just like one single line of thing, and it is grounded with a very good conductor, and it is excited with the one AC signal. So like this, and here it is a lambda by 4 length, and here it is a lambda by 4 length. So the total length becomes is equal to a half wavelength. Okay, and it is a horn antenna. Okay, so the first one they given that the rhombic antenna is a non-resonant antenna. So what is the difference between the resonant and non-resonant antenna is nothing but if the resonant antenna means it is having the two directional antenna, that means it is having the front wave and the back wave. But while coming to the non-resonant antenna, it is a unidirectional antenna. Okay, so simply we can say that resonant antennas are the bidirectional antennas, and the non-resonant antennas are the unidirectional antennas. It is only having the forward waves, and while coming to the resonant antennas, it is having the forward waves as well as the backward waves also. So it is a main difference. But while coming to the rhombic antenna is a unidirectional antenna. That means it is a non-resonant antenna. And while coming to the Marconi antenna is not a wideband antenna. Okay, it is having the narrow band, so it's also the correct thing. And coming to the horn antenna is best excited from a waveguide. So if you see this horn antenna, only this part is a horn antenna, and if you observe this one, it is the waveguide. That means always the horn antenna has to be excited with the waveguide to avoid the losses. So with the help of this explanation here, all the three given options, given points are correct. So the second option is correct, that is A, B, C are correct for this given antennas. So these are all the questions given in the UGC NET June 2019 regarding this electromagnetic waves and microwaves and antennas. So by these questions, you can understand that there is no need not to go in depth about the subject. Just go through the main formulas, just formulas and the basic concepts. Then you can answer the questions from this electromagnetic waves and the transmission lines. Thank you.